Let us see few more questions on recursion, which are tricky questions basically. Okay, so just because they are tricky, I'm keeping it optional. Although this is not optional video in the sense that if you watch it, it will be definitely useful. So it is not optional video, but if you find those recursions to be very tricky, then it is optional video, right? I mean, in the sense that in gate computer science also they have not asked very tricky questions from the linked list recursion, but they may ask, right? And these are not very tricky. I mean, once you understand the things, you will really appreciate that how it is happening, right? So let's just see that what is the real recursion in linked list, right? So suppose that they ask us to write a function which is insert rear, okay, that intend to insert a node at the end. So for example, suppose you have any linked list. So let me take the previous linked list, which is 47532. Okay, suppose you have this linked list 47532. Okay, now let's suppose in this linked list I want to insert rear. So basically, what does this mean? It means that I want to insert at the end, right? So here I want to insert at the end something, okay, maybe 100, maybe 10 or anything. Okay, so basically let's suppose I want to insert here 100. Okay, at the end I want to insert, and then this is null. Okay, this is what I want to do using the recursion. Obviously using the recursion, I mean, not using not using the normal loop method. It will be comparatively easy, but recursion, we want to really appreciate the recursion, right? So we want to really understand the recursion. So let's just do it using the recursion. Okay, so how you think we can do it? See, let me let me just try to build some intuition, try to put some ideas here and there, and then we will see if those ideas are working or not. Okay, we will run the code definitely. So what I want to kind of, I can say that, call the same function, right? So basically I will be calling the same function, and data means like 100, right? Whatever I want to insert, that is the data. Okay, so I will be calling the same function, and which is insert here, and obviously I will be going to the next, right? Going to the next of it with the same data. So this is something seems like a logical step that I want to do, right? But if I'm reaching at this point, right? If I'm reaching at this point, which means I can keep on going, that's fine. But the moment I reach at this point, which means the base case could be something like this: head dot next, right? Head dot next equal to none or is none, right? Is none. In that case, I have reached at this point, right? I have reached at this point. So the moment I reach at this point, I will create a new node. I mean, you can create before also, but let's just create a new node. So basically, let's suppose there is a class called node which I have already defined. Okay, and if I pass 100, then it will be creating a new node, right? So suppose my new node name is something like n1. Okay, n is my new node. Okay, so I've created a new node, and now all I want to do is the moment I reach here, okay, this is the base case, head dot next equal to n, right? Or you can directly write like this: head dot next equal to node of 100, right? Equal to node of 100, right? So the moment I reach here, I will be just asking it to point to the next thing. Okay, and then obviously I will not be calling this. So either you can write this in else part, or you can directly write return here. Okay, let me write return here, or you can directly, you can also write this in else part. Other like I mean to say that I don't want to execute this, right? If I'm executing this, if I don't want to execute this, so it seems like very logical. I will be, if it is not a base case, I will be going further. The moment I reach, okay, at this point, head dot next, the moment it is none, I will say that let me just point it to 100, and then return. That's all I want to do, right? I just want this to point here. So let's just see if this is working or not. Okay, so let's just quickly, so basically I have already written the prototype. Now I just need to write this, which is like if head dot next is none, which means this is the last node. In that case, I want to do something which is that head dot next equal to node of 100, right? And then I want to return. Otherwise I will be just calling the same function, which is insert rear, okay, head dot next with the same value or data, whatever you want to say. Okay. uh so yes, that's what I want to do. So let me just print also. So print linked list. Okay, so print b4. Let me print it before, and let's also print it after, right? So there's a function that I've already written, which is print linked list, which just take head and it will be printing. Okay, so before it will be the case, and let me also print after. So after. Okay, so let's just see what it is happening. Yes, so before it was 47532, and after also it is 47532. Because I've not called insert rear. Okay, so I've not called insert rear, which is basically head comma 100, right? I mean this value basically. Okay, so now let's just run this. Let's see what's going to happen. Yes, that's great. That before it is 47532, and after it is 47532 and then 100. Okay, so I hope you got to understood this. Okay, so basically what I'm doing, I'm just going further, going further, and then ultimately I'm saying that okay, let me do one thing. If it is the last node, then I will be just asking it to point to the last node, and immediately I will return. Okay, that's all. I don't want to do anything else, right? So if you don't want to write return, then also it is fine. You can just write else. I mean, I don't intend to basically execute this in this case. So basically before it will be, I mean, it will be already 100 because 100 I have just appended. So if you want, let me just reset the linked list. So actually I have already written the code here, print linked list and all. Okay, so this is a small code. Okay, I have already written to create the linked list. Now the linked list is again reset. Now let me run this. See, this is 47532, or and then 47532 100, right? I mean, if you don't want return, that's fine. Okay, see, it doesn't matter if you write return here or not, because I will just do everything very nicely, but I'm just telling you that if you write return here, then also it won't matter. I mean, it is basically the same thing. Okay, if you don't write return, then also it is the same thing. Okay, so let me do one thing. Let me just walk through this code very nicely, and let me show you that why this is working. Okay, and then we might also see some other variation of the same code. I mean, some other way to write the same insert rear. Okay, so basically this is very good and working code. Okay, this is a working code, right? Now let's just see why this code is working, right? So let me do one thing. Let me take this same linked list and let's just see why this code is working. Then probably you will get to understand more. Okay, sure. So basically initially this 2 is basically pointing to null. I mean, currently it is pointing to null, but later on I just want to add 100 here, right? Okay, see what is happening whenever you're calling. Okay, whenever you're calling this insert here, let me just do one thing. Let me little bit increase the size of this. Okay, so whenever you're calling this insert here with the head, so head is basically, you can say, currently pointing to 4, right? I mean, head is something which is pointing to 4, right? And then it is basically saying, so basically it is saying that now you just call the next function with the head dot next. Okay, and the value is basically a local variable every time, which is 100. So here also value is 100. I mean, I'm just sending the value. Here also value is 100. Okay, and then here I'm saying head is pointing to this thing, right? And similarly head will keep on be pointing to this thing till this point. So basically head is pointing here, head is pointing here, and then head is pointing here, and so on, right? The moment it sees this, then head dot next, since head dot next is null, right? I mean, basically it is the moment it is calling with 2, then head dot next is none. In that case I will say, okay, let me create a new node. Okay, now I will be creating a new node, right? And then I will ask it to point here, right? My job is done. Okay. I will simply return, because I will just see that okay, there is nothing else to execute, so I will just simply return. And previous calls also, like after this call, there is since there is nothing else to do, so they will just simply do nothing, right? They will just say okay, let me just return, right? So they all have nothing to do. I mean, this is the last thing that they have to do, and then they will just simply return, right? So the thing is that using this head, right? Using this head, I reached to here, okay, using the recursion, and then I'm just pointing it. That's all, right? That's how it is working. Okay. Now, let's see if we can write, the similar kind of insert here, uh, with some other variation. Okay, just to see, gate will not ask you to write any code, but these exercises are there to just make us more familiar about the recursion, right? So let's just see if we can do something else with the same insert here, and we can write the code such that it also works fine, right? So you can, I mean, this is just an out of curiosity, maybe we are not able to succeed, maybe we are able to succeed, right? Okay. So one thing is, by the way, for sure, I mean, obviously you have to do one thing, which is that you definitely have to keep on going, right? You definitely have to keep on going with head dot next equal to data. I mean, this is something that you obviously have to write. Okay. Now let me say one thing, that let me, instead of stopping at the last node, let me stop at the none, which means if head is none. Okay. If head is none, which means I'm going till none. Okay, I'm going till this point, right? I'm going till this point. Then in that case, I will create a node, and I want, okay, I will create a node, but I want this to be pointed by the previous thing, right? So see, the thing is that I will create a node here also. Let me just tell you that what is happening here. Okay. So basically, you keep on going, and then head is none. Then I will be creating a node which is like node data. Okay, node data. Like this, I will create a node. This is a class using which I will create a node, right? Okay. And then how will it work? Then I want something, this node, right? I want this node to be pointed by something like, I mean, the previous thing, right? So whoever is calling, right? Whoever is calling this. So just when I said that whoever is calling this, my doorbell has ring and has got rung, and then someone has actually called me. So anyway, so I was saying that it should be pointed by whoever is calling this, right? So basically, whenever it is null, I mean, at least I should be basically returning, right? I should be returning this, right? I should be returning the reference to this. And then I will obviously be doing something like this, but I have to do little bit of modification here and there, right? So let me directly show you the code. I mean, let me directly basically try to write the code. So the thing here is that I will be definitely writing, I mean, here I will, this is another version, right? I will be definitely writing insert here head dot next. But we need to understand this little carefully, that I mean, what how to make the links, right? So let's just see that what is happening. So by the way, this is the previous version, and we have already seen the previous version, but now I'm telling you the another version, right? So basically our linked list is this. 4 is there, and 4 is pointing to 7, and 7 is pointing to 5, 5 is pointing to 3, and 3 is pointing to 2, right? And we want to insert at the end. So one thing you notice here is that here this basically you have whenever this head is none, then we will be creating, right? Then at that point in time we will be creating, right? So suppose we create, let me just change the color. So suppose we create, a new node, right? And there could be any value. Let's suppose this is 8 or 100 or something, right? Let's suppose this is 100, right? So suppose we create a new node which is with 100. Now this new node will be created, and then this has to return, right? I mean, we are returning directly this new node. Now the point here is that who will be catching this new node, right? So I told you that whoever is calling this, right? So basically you can say that this 2 should be catching this 100, right? This 2 should be catching this 100. Now the thing here is that how to make sure that 2 is catching 100. Okay, so just think with respect to 2. Okay, just think with respect to 2 that what is happening with respect to 2. So for example, that initially you are calling, then head is pointing here, then you are calling, then head is pointing here. Okay, then you are calling, then head is pointing here, and then you are calling, head is pointing here, and then you're calling, head is pointing here, right? Okay, so now we need head dot next, right? Add this two. See, with respect to two, you just see, right? So whenever you are at two, then you need head dot next to point two. Whatever the recursive function call you are doing, okay? I mean, whatever this return, I mean, whatever you null return, basically, right? So basically, you need head dot next. So which means, see, just try to understand here. This is little counterintuitive, but you will get it, right? So we need head dot next to point to this, whatever this recursive call is returning. See, whenever you are at 2, okay, at that moment it is basically null, right? You can say it is null or none. Basically you can say it is none, right? So whenever you are at 2, I mean, with respect to 2 only, you are basically calling with none, right? None comma value. So none comma value is the box of 100, right? I mean, this basically will return the box of 100, the pointer to 100, or this box. Then with respect to 2, I think this works fine, right? I mean, head dot next should be pointing to this. See, we will be we will be seeing this very carefully, we will be analyzing it, but just I'm trying to build some intuition to write the code. Obviously the writing code is not important, okay, but still if you understand it, then you will be able to solve questions very easily, right? So what we are doing, we are basically saying that uh like head dot next equal to insert here head dot next comma value. So I think this is very first time where this recursive function, whatever this is basically recursive call is there, it is whatever it is returning, that is getting pointed by head dot next or something. I mean, previously also we have done few exercises, right? Previously also let me just show you. Previously also we have done few exercises, but at those times, like this is sum or something, but at those time, like we don't we are not having, it is not returning something, some pointer. Okay, previously I think whatever exercise we did, it was not returning some pointer, right? I mean, we had the recursive calls, but it was not returning some pointer, right? So but it is the very first time that I'm asking recursive call to return some pointer. Okay, so because I want to understand this linked list recursion very carefully and very nicely, so that is why we are having those kind of variations. So basically, this will do what? This will, if it is null, it will return 100, right? But what if it is not null? Which means, what is your expectation? Okay, see, if it is null, then head dot next is good. But if it is not null, suppose you are at 3. Okay, if you are at 3, then this is basically 2. I mean, this is like kind of pointer to 2, pointer to 2. Okay, and you are inside the 3. So what is your expectation? You should be basically, I mean, whenever you are calling it, you should be getting, I mean, you should be getting the pointer to 2 only, right? I mean, you should be basically getting whatever you are passing, in the sense that, see, if it is null, it will be 100, right? It will be 100. But just think with respect to 2, with respect to 3, whenever you are here, okay, whenever you are here, at that point in time, what is your expectation? You want to point to 2 only, right? You want to point to 2 only. So basically whenever you are at 2, see, again I know it is, little counterintuitive, but again, just think with respect to 2. Whenever you are at 2, right, you have two jobs. Okay, one job is that head dot next should be pointing to whatever, I mean, you are getting. Another job is that 3 is waiting, right? I mean, at 3 also you have written head dot next equal to something, right? So 3 head dot next, 3 here also head dot next is waiting, right? So your job is that whenever you are true, your job is that you return the pointer to as it is, right? So which means we will be returning. See, don't worry, we will understand the all the things very carefully, but little bit I'm telling you, okay, I mean, I'm just trying to make some sense here. Just try to see that we will be basically directly returning head. I mean, whenever you are at 2, you will return the head as it is, okay, to whoever called. See, if it is not base case, if it is not a base case, if a head is not null, right? If head is not null, I will return 100. Sorry, if a head is null, I will return 100. But if a head is not null, then I will return the head itself, right? Because earlier things, this 3 is waiting for something, right? In 3 also you have written a head dot next, which is waiting for something. And then there you want the pointer to 2 on to pointer to 2 only. At 5 you want pointer to 3. So don't worry, let me do one thing. Let me first, let me first run this program, and let's just see what is happening. So maybe, okay, let me just run this program. So basically, here before and after, let's just try to print it, right? So before and after, so let's just see. Okay, so actually I was already having 100, but yeah, so let's just reinitialize this. Now let's just try to print it before and after. Okay, yes, so before it is 47532, but after it is 47532 are you getting my point? So why it is happening? Now let's just understand it. Okay, now we will understand it very carefully. But till now, like little bit, you are convinced that that basically we are having something, some recursion, and somehow it is working, right? So basically, we are saying that I mean, there are multiple ways to understand this recursion. So we will try the best possible way. Okay, but intuitively, I am saying that if it is null, you are basically returning this 100. If it is not a base case, if it is just a, I mean, if you are here, right, like that, right? Then you have to return the pointer to itself only, because this thing is here you have written head dot next. Okay, so here you have written, I mean, everywhere you have written head dot next, right? Here also head dot next you have written, which is waiting actually, right? Which is waiting for something. Okay, so it is waiting, so you should be returning 5 itself, right? So let's do one thing. Let's just try to let's just try to understand this very carefully. Let me just do one thing. Let me just take the screenshot of this, and then let's just go to the next page. Okay, okay, so let's just paste this screenshot on the slides. So basically you want to insert at the end. Now let me paste this. So this is, you can say, another version, right? And let's just see how this is working. So this is kind of another version, and let's just see how it is working. See, you have a linked list which is 47532, right? So let me write 47532. So this is 4 7 5 3 and then 2. Now let's just analyze this very carefully. Okay, so let me put this on the side, and let's just take this on the front. So what will happen? Let's just see. Initially you are calling with this 4, right? So initially there will be head which will be pointing to 4. Okay, now what I said head dot next equal to insert rear head dot next comma value, which means at this point in time there is head dot next here itself. It will point to, okay, it will point to, notice here is that it will point to insert rear, I mean whatever this recursive function is calling. So basically it will start pointing to whatever this recursive function return. So currently I don't know what it is returning, but I'm just waiting. So basically just assume that this link doesn't hold anymore. I mean, I will be basically pointing whatever this recursive call return, right? So whatever this return, I will be pointing to that. So that's why I can say I'm just waiting. Okay, it is just like kind of waiting, right? Now you are at 7. Okay, now you are having a recursive call. Okay, and ultimately I will be returning head, which is fine. Okay, you can write return head. Ultimately I'm basically doing two things. I'm first calling a recursive function and I'm waiting. Okay, so this link is kind of okay broken. Okay, not exactly, but because I have not modified head.text now, but just for the sake of understanding, you can say this is like kind of broken and I'm just waiting. Okay, so whatever it returns, I will be basically pointing to that only. Okay, this link doesn't make any sense actually. Okay, but since I want to insert at the end, so my job here at the 7, my job is to return. I mean, every time since I'm returning head, so it will return the pointer to 7 itself. Okay. So see here also, we have a head pointer, which will be pointing to 7. Here also, we have head dot next, and it will also be waiting. Okay. It will also be waiting to the next thing. So which means you can say this link doesn't make any sense, and obviously ultimately I will return head. Okay, so this return head is common, okay, everywhere. Similarly you can say there will be some head, okay, which will be pointing to 5, and then this will also be waiting for head dot next will be waiting for the recursive calls whatever you return to me. Okay, and then which means this link doesn't make any sense as of now. Okay, and whatever it is, it will be overwritten. Okay, so now you have some head which is pointing here, and then I'm just having a recursive call which is head dot next. Okay, and it is also waiting for this function to return. So whatever this is, it doesn't make any sense as of now. Okay, because it will ultimately be overwritten, and then head will be pointing here, then it will be also calling head dot next, and then it will also be basically calling the recursive function, right? Now interestingly, this is the first time this recursive function will return. Okay, this is the first time this recursive function will return, and it will say that okay, there is 100, I have made 100, this is null. So it will return pointer to 100 itself. Okay, pointer to 100 itself will be returned. Now this is since this is waiting. Okay, just notice here is that this is waiting for whatever you return to me, and I'm returning the pointer to 100. So which means this is the first time I will say that link is getting established. Okay, earlier I was just saying link is getting broken, but now this link will get established the moment it returns, right? Because this will be stored in head.next. Okay, so this will be established. Now what it is returning, every function is returning head, so basically this is also waiting, like this is basically waiting whatever you return to me. Since I'm just returning the pointer to 2, so it will be pointing here, and now I'm returning the pointer to 3, so it will be basically it was waiting, so it will be reconnected. Now here I'm waiting for this, and it will also return the head, which means pointer to 5. It will also return the head, which means pointer to 7. Okay, and it will also return the head, which means the original this head. Okay, the head is this. Okay, so I hope you understood that how this is working, right? So basically, just trace this, right? Just trace that what is happening. Then you will get to understand that how it is working. Okay, so head will be, you can say head will be basically finally written, and head is pointing to 4 only. So very clever idea, very interesting idea. I am saying that if it is a base case, I will return the pointer itself. Okay, if it is not a base case, okay, and here also before that I can say that whenever I'm doing the recursive call, okay, this is the very first time I'm asking the recursive call to return some pointer. Okay, whenever I'm doing the recursive call, I'm saying that okay, this should be basically returning the head only. I mean, or in other words, like let's just first understand that whenever I'm here, okay, so basically I'm saying that head dot next will be pointing to whatever the next call return to me, and next call should be returning the head only. Okay, every call is basically returning the head only if it is not a base case. If it is a base case, it will return 100. If it is not a base case, then you first understand. Okay, just forget this. Okay, if it is a base case, it is returning, you just see the return statements, right? If it is a base case, then it is returning 100, pointer to 100. If it is not a base case, then I'm just returning pointer to 2, pointer to, I mean the pointer to itself, right? So if you're writing head dot next equal to, which means since the next call will be basically, if you even consider any middle case, the next call will be basically returning the pointer to 7. I mean, I'm passing the pointer to 7. It will be the head for the next call, and I'm returning the head, right? It's like that, right? So I'm passing head dot next, but ultimately it is a head for the next call, and I'm returning the head only. Okay, so it's like kind of whatever I'm passing, right? Whatever I'm passing, it will be stored to head, and then I'm returning the head. So whatever I'm passing, it will, as it is, we will it will, I mean, as it is, you will be getting the same thing. It will be written as it is, whatever you are passing, right? So I hope you're getting this. See, see, let me just go to the code again. Okay, so let me try to write the whole code once again. See, if head is none, then you are returning the pointer to 100. I mean, you are basically saying that last pointer I will be returning. Okay, 100. So if head is none, so I will be returning the pointer to 100. I will create a node and I will be returning that. Else, otherwise, what will I do? I will return whatever I'm passing. Okay, return head. Okay, and then at any moment, head dot next should be pointing to whatever the recursive call, the next recursive call is getting. Okay, here I will be getting the same pointer, but still, right? Head dot next equal to insert here head dot next, because I need to increment. I need to go further, right? Something like this. Okay, so that's how it is working. This is very nice code, and in fact, I've taken this code, the as it is code from CMU University. So this code is not written by me. I've written it in front of you, but it was actually taken from CMU University. But yes, this code, it was written by me. Okay, it was written by me. But this is I have taken, okay, taken from CMU University. So this is taken from CMU University, right? Now, in fact, they have also, tried to give a proof of correctness, which is almost same as that we have discussed, few later times. So let's just read their proof of correctness also. I mean, they are just giving some intuition or some proof that why it is working. Okay, again, this proof of correctness and these things I have taken from CMU University only. So basically, if you remember, then I told you that just see if the base case is working, okay, and then if it is working for the sub problem, then it will work for the larger problem. So that's what they are saying. So note the proof of correctness. So actually, I've written the proof of correctness, same paragraph on the next page, but in little better way. Yes. So yeah. So basically, this is the code, right? I mean, I've used here L instead of head, but that's fine. Okay. So this is the code that we have. Okay. So this is the same paragraph, but I have just given some new lines, so just I can read it. So what they are saying, for the base case as an empty list, this method returns the correct answer. If it is empty list, then basically it is returning the correct answer, which is insert here, right? The recursive call is applied to a strictly smaller. I mean, obviously it will be a smaller linked list. Now, assuming, okay, now this is important, as I told you, right? Assume, right? Assuming that it is working for the smaller list, right? So this is working, correctly returns. Assume that it correctly returns a reference to the linked list that contains all nodes after the first, in which new node containing the value is inserted at the rear. So assume that it is actually inserting, okay? Assume that if it is actually inserting, okay, and it is basically giving me the head pointer basically, which means if it is actually inserting this 15 at the end, and then it is giving me pointer to 91, then I think there is no problem, right? So a new node is inserted, then then storing a reference to this is also working. Basically, it is like that you assume that if this is working, then whole thing will work, right? Something like this. And base case is working, then whole thing will work, right? So the thing that I wanted to say here is that gate will not ask you Gate will not ask you to write the code. Gate is not subject to exam, and Gate will ask you to just identify what this code is doing. Maybe they will give some question like this. They will say that, okay, after this call what will happen if the initial linked list is this, then after this call what will happen if you are passing 100 here, right? Then your answer will be, one of the option will be 1 2 3 400. Then your answer will be this option, right? You will say, okay, option A is correct. Something like this Gate may ask. But for that also, you need to visualize that what this is doing and how to do it. So basically there are like intuition. Okay, you will say that, okay, this is working for the suppose this is working for this, I mean the smaller list, then it is working for the whole list, or the best way is to do this kind of exercise. Okay, so basically you just see that what is happening. If you do for 1 2 exercises, then you will get to understand things very properly. See, I completely understand that initially it might feel very tough. Okay, so I will be very honest with you. When I first saw these recursive codes in the linked list, then I was not very confident. I also got some kind of fear that, okay, how things are working. But when I just iterate it, when I just dry run it, when I just made this kind of diagram, then I got to understand that, okay, this is working like this, right? So if it is your very first time seeing these kind of codes, then it is fine if you are a little bit afraid. Okay, this is good. But it will overcome. Okay, automatically it will get overcome. It automatically you will get to understand things very nicely as we proceed further. Okay. So yeah, see this question. Gate will ask this kind of question. Again, this question I've taken from CMU University. I mean, this code, basically the same code, right? So the edge is same code. Instead of L, I was using head. The edge is same code is there. So Gate will ask this kind of question that if you're calling with 8, then what will happen? So as you know, we have just solved this. So you will be inserting at the end. This is actually inserting at the end, right? Gate might say mystery instead of insert rear. They might change the function name fun mystery so that you don't get the hint. Okay. So these kind of questions Gate may definitely ask. Now let's just solve more such kind of questions. So the same thing, okay, the same question, but instead of L, I'm just using L dot next. Okay, I'm using L dot next. I mean here instead of L, I'm using L dot next. Just try to solve this question. Okay, once you solve this question, you will get more idea that how things are working. Let us now do the next question. So here, this is like similar to the previous question. It is just that we are returning L dot next, right? And this will make a lot of difference. So let's just see that what they are asking and how to solve this question, right? So basically, they are saying that what will happen if we run this code on this linked list, right? So let's just write this linked list here. Now let's just run this quickly. So basically, you are having many recursive calls, and everyone will be calling like everyone will be having their own head, right? So basically here, let me just write h, head is pointing here, then it will basically h dot next, basically it will wait, and then whatever the next recursive call returns, it will basically point to that, right? Now similarly, and it itself is returning h dot next, which is okay. So similarly here, the new head will be here, it will be pointing to this, and the head dot next, basically this link will not be here anymore, and then it will be pointing to whatever the next recursive call return. Similarly here also, this will be pointing, the head will be pointing to 5, and then it will be basically waiting that whatever the next recursive call returns, right? Similarly here also, h is pointing to this, and it will also be waiting to whatever next recursive call returns, right? So whatever next recursive call returns, it will be waiting for this. Now here also, h will be waiting, h will be pointing to this, and a head will be pointing to this, and then it will be waiting for whatever the next recursive call returns, right? So you can say the next recursive call is this only. Okay, so I mean here to the null. So basically this is the next recursive call, and in the next recursive call, so basically the next recursive call is for the null or none, right? So this is the next recursive call. So it will say that I will no longer be pointing to this null, right, or none. I will be basically pointing to whatever the next recursive call return. And here the head is actually null or none, and then it will say let me return the pointer to 8, right? I will be creating a box of 8 and I will be returning the pointer to 8. So basically 2 will start pointing to 8, right? 2 will start pointing to 8. Is this fine? So it's just kind of like you can say forward fetch and then backward fetch. In the forward fetch we call, and this is the first time we are returning, so 2 will start pointing to 8. Now can you tell me that that where does, so basically you can assume that there is no function, like I mean there is this is not there. Now 2 is just pointing to 8, right? Now can you tell me what does this 2 return? So 2 will basically return h dot next, head dot next, right? So which means 2 will return the pointer to 8 only. 2 is also returning. See, notice here is that 2 is also returning the pointer to 8 only, which means that 2 is returning the pointer to 8, which means that 3, okay, this particular thing, this 3 will also point to 8. Okay, this 3 will also start pointing to 8. And 2 is already pointing to 8, but 3 will also point to 8. Are you getting my point? Why that is happening? Because 2 will return h dot next, right? Head dot next. So 2 will return the pointer to 8 only. So that is why 3 will also start pointing to this. And then this will return the pointer to h dot next, right? So this will also return the pointer to 8. So actually what will happen, that this 5 will also start pointing to 8. Okay. 5 will also start pointing to 8 because this is also returning h dot next, right? So this will also start pointing to 8. And then what will happen next? So this 5 will return, 5 will again return h dot next only, which means h dot next is pointed to 8 only. So 7 will also start pointing to 8, right? And then 7 will also return the h dot next, which means the 8 pointed to 8 only. So 4 will also start pointing to 8. Okay, so you can say 4 will also start pointing to 8. Okay, and then 4 will return h dot next, which means pointer to 8. So wherever I'm calling this function, okay, so it will return the pointer to 8 only. I mean, the finally, let's suppose if I'm writing head equal to fun head comma data, which is 8, something like this, right? So now this final head, okay, final head, this will also start pointing to pointer to 8. So basically ultimately it will look like this. 8 is here, and then 4, there's a box of 4 which is pointing to this. There's a box of 7 which is pointing to this. There's a box of 5 which is pointing to this. There's a box of 3. There's a box of 2, okay, which is pointing to this. There's a box of 2 which is pointing to this. Okay, everyone is pointing to 8 only, right? And then there's a head which is also pointing to 8. Okay, obviously there is no way to reach to these nodes, so that's why in Python they automatically get deleted. Okay, but it will look like this until unless they delete. I mean, it will look like this. So ultimately your linked list is just head is pointing to 8. Okay, now I think you are getting right the points, I mean how things are working. So basically ultimately you will say C is the answer and head will start pointing to 8 only. So C is the correct answer here. Okay, so let me just go to the next page, and if you ask me that what is the answer, then I will say C is the correct answer. Right, because everything is pointing to 8, and head जो final head है, okay, that is also pointing to 8. Okay, this final head will also start pointing to 8. I mean, in the question I have not written exact words, so pardon for that. I mean, I should have written head equal to fun head comma 8, and then where does this head return? I mean, this left hand side, right? Where does this head point to? Okay, what is the final linked list? So basically the head will also point to 8. So that's why C is the correct answer. I hope you understood this, right? Okay, so basically the best way to solve these questions is like I mean, try making these diagrams. Okay, this head and head dot next is waiting. This is the first return. This will also return pointer to 8. So this will also return pointer to 8, like that, right? This is the best way. Let's just try to see if we can, without making the diagram, if we can make some sense here. So basically what we are saying, if it is a base case, then return the pointer to 8. Otherwise you return. Okay, so basically you are passing something, I mean you are going to next, and then you are returning the pointer to next. Okay, which means you are not returning, earlier we were returning the head pointer, but here we are returning the pointer to next. I mean, if we are returning the pointer to 8, so we are returning the pointer to 8. and then here this will also return the head dot next, right? So basically it is waiting, and it is also returning the pointer to 8. So basically it will start pointing to 8 also, right? I mean, everyone is returning pointer to next, and pointer to next is actually 8 only, right? For this is 8, and then I mean, it is pointing to 8, then it will return pointer to next, which is 8, so it will also start pointing to 8. Now head dot next is again 8, so it will also start pointing to 8, like that, right? So ultimately, if you run this code, then you will be getting, okay, you will be getting 8 only. Understood? If you want, I can even run this code. So if you want, I can even run this code. Let me change with this fun, and then let me write before after. Okay, so this is fun, and this is head dot next. That's the only change, right? That we are doing, head dot next, and this is fun. Okay, this was 8. Okay, let me reinitialize the linked list. Let's just see what's happened. See, earlier it was 47532. Now it is just 8. Okay, pointer to 8. So I hope, I mean, you got to understand that what is happening here, right? Okay, so everyone is basically returning the pointer to 8 only. Very weird code, but actually the purpose of this code is to make sure that you understand linked list recursion. Okay, that how it is happening. I mean, basically you should be able to make these type of visualization. Okay, once you start making these things, then things will be actually I mean, approachable, right? So let's solve more questions so that you get to understand things more. This is again very nice question, very tricky question. So even if you do not understand, this question, that's completely fine, because next two questions could be, more trickier, right? I mean, trickier than among all the questions that we have seen. So 3 and 4 questions are actually, these two questions are more trickier, I can say. Okay, so let's just try to solve these questions, what they are saying. So they are saying that there is some function called remove first. Okay, what it is doing, if head is none, it returns nothing. If head dot value equal to collect, so basically I will be passing some value also. So for example 2. Then the moment I find it, okay, so let's just do one thing. Let's just go to the next page, and uh, let me first see that what it is doing, right? So basically I'm saying the moment I find, so basically there will be many calls. Okay, so the moment I find the value, which is 2 actually in this case, right? 2. The moment I find out that value, I will do one thing. Let's suppose h is or head is pointing here, and since it is matching the value, I will actually skip this. Okay, skip this means I will basically completely skip this, and I will return. I will say that, okay, at that moment the things are done, and let me directly return. Okay, directly return the pointer to the next linked list. Okay, I will be basically returning the pointer to this, right? I mean, whatever it is waiting. So basically this is waiting for head dot next. Basically this will be, I will be returning, right? Something like this it is doing. Okay, so let's just dry run this. So initially head is pointing here, and then head dot next, as usual, it is basically waiting, okay, something to be written. Now head is pointing here, and then since this is matching, right, since this is matching, so that is why what will I say, it will return the pointer to 2. So basically now at this moment only it will start returning. I mean, there is no recursive call. Okay, so this is not a recursive call, you will just return directly. Okay, so you will return directly, you will return the pointer to this linked list, right? I mean, pointer to 2. And here obviously this head dot next is waiting, okay, whatever you return to me. So I will basically say, let me just, connect to whatever you return to me, right? I mean, actually this will not even get executed. Okay, all of this will not get executed. It will just say, let me just return to me. So, and then this itself will return head, right? Head means the pointer to 1. So finally you will say 1 will start pointing to, you will skip this, 1 will start pointing to 2, which is pointing to 8622, something like this, right? And then null. Okay, so basically you will just delete it, or you will just skip this. So okay, so something like this is happening. So you can say that D is the correct answer here, right? So D is the correct answer. Let me go to the next page, and let me just paste it, so that whenever you see this again, you don't see the answer directly. Okay, You can just try it out, and then you will be able to realize that D is the correct answer here. Okay. Now let's see this question, which is actually tricky. Okay. So let's see this question. Here it is the same question. I mean almost the same question, but here I'm just having the recursive call here. I mean earlier it was just head dot next. I was just returning head dot next. Instead of that, I'm writing some recursive function here. Okay. So let's just do one thing. Let's just try solving this question. So basically, I will be having the similar thing, which means there will be many recursive calls, right? So here one, here, here. So there will be many recursive calls. So let's just start with beginning. So head will be pointing, or L will be pointing to this. Okay, you just treat it like head. And since the base case, I mean this case is not valid, so basically it will say that okay, let me just call this, right? I mean I will be just here, and then I will say okay, let me just wait for whatever you return to me, right? Let me just wait for whatever you return to me. And then here I will say that okay, h is pointing here. Since it is matching, right? Since it is matching, I will be basically calling. Okay, I will not be, see, interestingly, I'm not writing l dot next or something, right? I'm just directly returning. Okay, so which means I'm not worrying that okay, what does this point or not, right? I'm just saying I'm not interested that okay, what it is pointing. I'm just saying that I will return something. I mean, I will basically hand over this, right? I will hand over the rest of the linked list, okay, to this. I will hand over the rest of the linked list to this. So I will return, I mean, this remove all, okay, I will return this linked list to this, okay, I mean, remove all of the remaining linked list, right? Okay. So basically now I will come here, and then h is pointing here. It will also say the same thing. It will say since I'm matching, right? Since I'm matching with this, so I will return the rest of the linked list, right? Now I will go here, and then I will say, so basically they will say that I will return the rest of the linked list. Now I will go here, and I will say that okay, here this is not matching with any of this two, right? Here I will say that let's do one thing, you know uh, so basically let's do one thing. Let me just wait for l dot next equal to wait for whatever this return to me, right? Okay, so now h is pointing here, and it will also say the same thing. Let me wait for whatever this return to me, right? Whatever this return to me. Now h is pointing here. It will say that let me just directly return this linked list. I mean recursive call of this linked list, right? Now similarly h is pointing here. It will say that let me directly return a recursive call of this linked list, and the moment h is null, okay, or none, okay, at that moment I will just return none. Okay, so I'm returning none here, right? And this is returning directly whatever the previous call is returning. I mean this is directly returning whatever previous call. I mean it has no contribution. So basically these two has no contribution. It will return whatever the previous call is returning. It will return the whatever the previous call is returning. So basically previously I'm returning none. So that is why it will be none, right? I mean the 6 will be pointing to none. Okay, and then this 6 will be basically returning l. Okay, so everywhere I'm returning l only instead of 2. Okay, I mean I'm returning h only instead of 2. So basically this 6 will be saying that now 6 is pointing to none. Okay, now 6 is pointing to none. So basically till now 6 is okay. Let me just go to the next page, and then let me just explain that. See, now 6 will start pointing to none, right? I mean at this moment, whenever 6 comes, it will start pointing to none or null, and then 6 will return the pointer to itself, which means 6 will return the pointer to 6 only. Okay, so whenever you return l, see, we generally don't return l dot next. I mean I have not seen the code where I'm returning l dot next. We only return l only, or l or head, which means I'm returning the pointer to itself. Okay, which means 6 is not I mean this link, okay, 8 6 is not broken. Okay, if I'm returning l, then it means the 8 6 will be intact. Maybe 6 has changed, right? I mean whatever 6 is pointing to, it might have changed, but this 8 6 is intact. Okay, so 8 will also return. Okay, so basically 8 6 is intact, and then 8 will also return the pointer to itself, which means it will also return what pointer to itself. And then this 2 will say that whatever the previous call is returning, right, whatever the previous call return, I'm returning the same thing. So it will also return the pointer to 8, it will also return the pointer to 8, and then 1 is waiting, so 1 will basically start pointing to 8, right, and then this is pointing to none, and 1 will return the pointer to itself, which means head. So ultimately you are removing all twos. Okay, so if you just want to remove the first two, then there was another code. But if you want to remove the all two, or all some data, then basically if you write some recursive function here, then it will be done, right? I've taken this question from CMU, and this is one of the trickiest question, okay, I can say, in linked list I have seen. But if you make the visualization, if you try to spend some time here, probably 1 hour, I will say that just spend 1 hour if you want, okay, and then it will be very very clear that what this code is doing. Okay, just spend some time here, then you will get to know that what this code is doing. Okay, so basically it is just a dry run. Okay, once you just dry run, then you will get to understand, then you just have the recursive calls. Then this 2 is actually skipping. Okay, it is saying that I don't have any contribution, you just return whatever the next calls are returning. Okay, l dot next, whatever the next calls are returning, I don't have any contribution, right? So I don't have any contribution, you just return whatever the next is returning. So it's just a bypass. Okay, bypassing. And 6 is saying that I will return the pointer to myself, right? Similarly, it is returning the pointer. Whenever you return the pointer to yourself, then the previous link is actually not broken. Okay, the previous links are not broken. Little bit you might have understood. See, this is the very first example which is very tricky. So that's why even if you have not understood anything here, that's fine, because this was little tricky. Not little, it was very very tricky actually. Okay, so that's fine, like you can even skip this question, but I just wanted to make sure that you also get the flavor of such questions. So that is why I'm having this question. I think that it's very rare, and I've not seen, at least in the coaching industry, I've not seen these kind of recursive linked list problems that anyone is solving in the coaching. Maybe they are solving, like, but I have not seen. Okay, most probably they are not solving, like I'm 99.99% sure. So the reason why I'm having this, because gate may ask anytime, right? I mean, we never know, and there has been many things that we teach, and no other coaching or no other, I mean, at least in the gate industry, people are not teaching, and gate asks these things, right? I mean, they include it once gate ask, but we include it before gate ask. So that is the difference, because we want you to prepare fully, okay, not partially. So that is the reason, like, I'm teaching you all of this. You should be able to understand the recursive code in the linked list. Okay, so it is not very very hard. If you make this diagram, then you will get to understand that what this removal is doing. It is just bypassing. Okay, it is just saying I will return whatever the next things are returning. Okay, and then if the 6 8, or if it is not 2, then it will return the pointer to itself, right? That's how it is doing. Very nice, very clever code, right? Okay, so basically I can say D is the sorry C is the correct answer here, right? C is the correct answer. Now, let's do this exercise. This is just random code, probably. Let's just see what this is doing. So they are saying if head is none or head dot text is none, then return head. So if it is last, I mean none or second last, basically. So you can directly return, I mean, return head, which means pointer to itself. Otherwise, basically what you do, head dot next equal to. Okay, so let me just try to solve this question. Basically, they are saying we want head dot next to be equal to head dot next, right? So let me just do some recursive call. So basically head will be pointing here, and then I'm saying head dot next, let me just wait, right? Whatever this 7 returns. Okay, the thing here is that I'm not passing the 7, so I'm directly skipping to the 5, head dot next. So basically I'm completely skipping the 7. Okay, I'm saying let me just wait for 5. Okay, whatever the 5 return. So basically there is no recursive call here. Okay, no recursive call here. I'm just directly waiting for 5. Then if you come to the 5, okay, so basically you can say that the 7 doesn't even exist now, right? I mean, for me it doesn't matter, right? Now if you come to the 5, then it will say that I will also do the same thing. I will just skip one thing. So I think it is just skipping one thing, right? I will also skip this 3 completely. I will wait for whatever this 2 written, right? I will point to whatever this 2 written, right? And then this 2 will say that since I'm the last node, so I will return the pointer to myself, right? So so basically it is waiting for whatever this 2 return. I mean 3 doesn't even exist now. Okay, so 3 doesn't even exist, so you can say now I'm waiting for whatever this 2 return. Okay, 4 is waiting for whatever the 5 return, 5 is waiting for whatever 2 return. 2 is saying that I'm the last node. If I'm the last node, I will return myself, right? So 5 will start pointing to 2, and then 5 will return head, right? So basically everyone is returning head instead of like if it is not 2 or if it is not null, right? So 5 will return the pointer to itself. So basically 4 will now point to 5, because 4 will point to whatever 5 return, and 5 is returning the pointer to itself, right? And 4 will also return the pointer to itself, which means that head will point to 4, which will point to 5, then 2, then null, right? Something like this. So basically it is skipping one. So you can say it is alternate delete. Okay, alternate delete kind of thing. Okay, so basically 7 3 will get deleted. So 4 5 2, 4 5 2 null, right? A is the answer here. 4 5 2 null. Okay, it was also a good question, but now you see that your speed of understanding the questions might have increased, right? Because once you understand these diagrams, okay, once you understand these diagrams, that how to make this diagram, then you can solve linked list recursion problem very easily. Okay, if not very easily, but at least it should be approachable to you. Understood? Now let's just see this question. In this question, again, I've taken all of these questions from CMU. In this question, they are saying search is a function that intend to search a given value in a linked list. Okay, so I want to search the given value. Head is none, then there is nothing. If head dot data equal to value, I will return the head. I want to write some code here, right? Okay. So I'm just basically I'm just searching, right? So obviously I will do head dot next, right? I mean it is like pointer, so I will not do dot data. Obviously I will be doing head dot next, and I will be just passing the value. So head dot next comma value. But if A is or B, right? I mean A or B, which one is the correct answer? So among A and B, actually, I mean, for the sake of working, it won't matter much. But ultimately, I want the pointer to the given value, right? So, for example, if it is, let's suppose 4 5 7 3 2, something like this, and if let's suppose I'm searching for 5, right? Then I'm expecting the pointer to 5. I'm expecting some return. Okay. So I'm not just expecting the call. I mean, I'm also expecting the return. Okay. So basically I can say that I'm expecting the pointer to 5. So you can say that here if you directly write this, I mean it will be just calling. Okay, it will be calling, it will be not returning, okay, to your final function. Okay, so wherever you're calling this, it will not return to this. So yes, question could be little more clear that what I want. Okay, so basically I want, you can see in the question, I want uh, pointer to, or the reference to the value. Okay, whatever this value, right? I want the pointer to this value. So if you want this, then obviously you will be basically having the return statement, right? So you can say that I need a return, so that's why A is the correct answer. You can even run this. So let's suppose if I run this, so I'm writing this code, and if you run this, so basically the exact same code I've written. Okay, so I'm expecting the pointer to node. Okay, let's suppose I'm searching for 5. So let's see if it is returning. Yes, so basically it is returning the pointer to 5. Understood? If you don't write return here, then basically it will be like none. I mean it will not be returning anything. So yes, so it is giving the error that none type has no attribute value, because pointer to node is actually none, right? It is not returning anything. So I hope you got to understand. So basically if you don't write return here, then if you don't write return here, then basically what will happen, that if you run on this, then see, if this the value is matching, then it is returning, right? I mean then it is returning. Then at here, but here I'm not returning. So basically I should be returning whatever, right, whatever I got from the previous call. Okay, so whatever I got from the previous call, I should be bypassing it, right? So for that, I need to write return statement if I need to bypass, or if I need to just carry forward it. Okay, if I need to carry forward whatever I have just got, then I have to write return statement. Okay, so these were few more questions, and with these questions my aim was very simple. I just wanted you to be more familiar with the recursion in linked list, and there is no intention to make the things tough. So that's why I made these questions as optional questions. But yes, you should be able to understand these questions. Okay, I hope you really like these questions, because it took some time to to collect these questions, to frame these questions, and to explain these questions. Okay, but those were really nice questions. Okay, so I just suggest you to spend some more time in all the questions. Okay, just try to make these calls and just see that what is happening. Okay, then hopefully you will be having the better idea. Okay, so thank you everyone. So that's all for this video.